This is one of my favorite lessons in integrating or antiderivatives, and that is the properties of definite integrals. So one of the big properties you got to realize here, really helpful, if you're adding or subtracting two different functions, you have multiple terms basically you're integrating, you can split them up and integrate them separately. That's definitely going to come in handy further down the road, and maybe even this very lesson. If you have a constant in front of a function, like, if you were to be integrating like 3 sine of x, you would just bring the 3 out to the front. And of course, you need that dx there, right? So that's all that one's talking about. So very similar rules to what we're used to. Now let's get to the cool ones. So if you're integrating from a to b, your lower bound is a, upper bound is b, you can flip those as long as you put a negative in the front. So it ends up doing the opposite of your answer. So you could flip these bounds. You usually want the lower number to be on the bottom, the higher number to be on top. That's typically the way we do things. So if it's not that way, you can flip it as long as you put a negative in the front. And that's typically what will happen. If like this was a 5 on the bottom and a 1 on the top, you would flip them so it's a 1 on the bottom, 5 on the top, but you would have to put the negative up front. And we'll see that in this video here. And then integrating from a to a, there's no area, there's no width to that interval. So that area is just going to be 0. I mean, you can think of that fundamental theorem of calculus. It would be f of a minus f of a, right? That would just be 0. That would technically be the proof of that. Very simple proof. And then last, adding integral. This one's where it gets a little more complex, but it's my favorite part. Integral from a to b plus the integral from b to c equals the integral from a to c. Now, how does that one make sense? Let me help you out with that one. I think that's not in this lesson, but for the next lesson. But let's talk about it anyways. Doesn't hurt to talk about it more than once. If you have let's draw kind of some graph here. So let's just say this is a, b, and c. So remember the integral, let's start with a to c. That integral is going to give you the area under the curve from here to here. So what this is saying is we can break it up. We can say, hey, let's do the integral from a to b. As long as b is between a and c. Wouldn't make sense otherwise. So basically, let's take the area. I'm going to put some color to this. We're going to do the area from a to b, and we're going to add it to the area from b to c. And we'll call that one, right here, from b to c. And if we add up those two areas, it's going to equal the entire integral from a to c. It's going to equal that entire area. That makes sense. If you take this region here in pink plus that region in blue, it would equal the entire region. That's all this is saying. From a to b, if you integrate from a to b, and then you from b is where we left off at, start from there and then go to c. That's the same thing as just going from a to c. So you can you could split this integral up into two different integrals as long as this number's the same on those two. That way just goes from a, ends at b, and the next one's going to start at b and then end at c will be that total interval. So think about that one. I think the next lessons more on that, I don't remember, but let me go ahead and use these properties for these questions. So for our first question, integral from 3 to 3. So they're giving us the areas from like -6 to -2, from -2 to 3, from 3 to 7. So the integral from 3 to 3, remember that's just that property that's going to be 0. Easy. Done. This one, same thing. That one's going to be 0. It's integral from 5 to 5. So pay attention to those. Those do pop up on AP. Free questions. Easy questions. All right, look at this. 0 to -4, that's a little backwards, isn't it? Remember, you want the lower number to be on the bottom. So that's going to equal negative integral from -4 to 0. Now the lower number is on the bottom, so now we can use the area that we see here in this graph. Because remember, this area that you see here is going from left to right. From left to right, it's -6. From left to right, it's 4. So that does make a difference. This is integrating right to left, which is the opposite. So from -4 to 0, it's -6. That's our area under the curve from -4 to 0. So this integral here is equivalent to -6. Don't forget there's that negative that's on the outside though. So -6 makes it a +6. This one, you're just adding up the two areas from 3 to 6. And they give us two graphs here. So you could split this up. That's what we were talking about earlier. So 3 to 6 f of x dx plus the integral from h of x. Notice this is not the one where we're splitting those bounds up, by the way. There's just two different functions. There's f and there's h. So we can just, they're being split up by the plus sign, so I'm splitting up the integrals by plus sign. Very important property, by the way, for integrals when we get more to the algebraic ones. So we would just add it up. F of x from 3 to 6 is negative 6 plus h of x from 3 to 6 is negative 2 for a total area of negative 8. Last one. This is that constant in the front, so we can bring that constant out to the front, negative 2, integral from 0 to 5 g of x. I like it when they put more rules together, like if they did 5 to 0, so we then have to flip it and change the sign out in the front and all that. But these are just using one rule, so they're pretty easy. Integral from 0 to 5 is 4, so this will just equal negative 2 times 4, which is negative 8.